Gotta take breaks.
Hello and welcome back to Calculus1. Today we are talking about graphing functions, which will definitely help since we have a no calculator policy. Many other schools have no graphing calculator policy during exams. You already know some of the basic techniques when you have one of those basic functions which you memorized how they look like, and then you can shift them left, right, and reflect and all of that stuff. That's all from pre-calculus 1. That all still stands. But now we would like to know how to graph, let's say, ln of x squared plus 1. We want to know how to graph sine x divided by x squared and things like that. So functions that are obtained by function composition and other crazy things. So let's dive into it. I first want to outline the entire procedure. So here's what I call the shopping list. So these are all the things that you need. First of all, we're going to start with the domain, and then x and y intercepts. Maybe I should number these rather than using. So number 1, number 2, number 3. We are talking about 3 types of asymptotes. We have vertical, horizontal, and slant asymptote. So 3 types. We also have the first derivative test, which will give us a lot of stuff. It gives us critical points. It gives us intervals of increase decrease, and also as a byproduct min and max locations. Number 5, second derivative test, which will give us inflection points and concavity. And finally, we might need additional points. Calculate 1 or 2. I'll just say might need those. And finally, number 7, graph. Boom. Now, if you separate all of these into... Why are you wet, man?
I jumped in the pool.
Do you have a hood attached to your... Oh, anyway. Domain, X-Intercept, Y-Intercept, vertical, horizontal, slant, critical points, increase, decrease, min, max, inflection points, concavity, up and down, and maybe additional points. So there's a lot of stuff. These problems can take anywhere from 20 to 40 minutes because there's a lot of calculations. And as I mentioned, for the exam, I'm going to break these problems into multiple problems, where you're going to have a problem on first derivative test with analysis, which takes care of number 4, then a problem for number 5, and then possibly, well, not possibly, definitely a problem where I give you all the information and you're just supposed to graph. So I calculate everything. There will be maybe 4 problems that will relate directly to this list. So you can see over here that this list is unity between what you learned in algebra, pre-calculus, and obviously calculus. So let's do this on two very simple problems first, and then we'll pick some from the book and work out two longer examples from the textbook, because first we want to know how to do this in general on a easier example. So the first example, let's say 1 over x. Say that's, now you all know how this looks like already, right? Hopefully, this you should. But let's pretend we don't, and we want to use calculus to figure this out. So I'm going to start with the domain and state that the domain is from negative infinity to 0, union 0 to infinity. So technically everything except 0, it's okay to plug in. And now X-Intercept. For X-Intercept, we set y equal to 0, and we see there is no solution. And for Y-Intercept, we set x equal to 0. And also get no solution because 1 divided by 0 doesn't exist. Yes?
Could you make the outside parentheses brackets, like the ones that are negative?
No. That means we include. We can't count to infinity. Only one person can count to infinity. Twice in 5 minutes. All right. So now we have domain, we have x and y-intercept. Next one is the vertical asymptote. Well, we set denominator equal to 0, use the limit if we have to. If you don't have to use the limit, if it's obvious, then just don't worry about it. So vertical asymptote definitely at x equal to 0. Horizontal asymptote, again, limit goes to infinity and all of that good stuff. Y equals to 0 in this case. And slant asymptote, none. So we're clearing all of this introductory steps. And now we are at our step where we do the first derivative test. So FDT, that's how I abbreviate first derivative test. We take the derivative and we get f prime is negative 1 over x squared if you take the derivative. And when you set this equal to 0, we get no solution again. Right, because we get negative 1 equals to 0, so no solution for this equation. So that means no critical points. But we still have the vertical asymptote, so we are going to partition at 0 and pick two test points, negative 1 and positive 1. And do our first derivative test, so like we did last class. So plug in negative 1, we get negative 1 over negative 1 squared, which gives us negative 1, showing that the function is decreasing. And we also check first derivative at 1, which gives us the same answer. So function is always decreasing, but there is a vertical asymptote at 0. So I'm going to say f of x is decreasing on negative infinity to 0, union 0 to infinity. So over entire domain, the function will be decreasing because of the first derivative test. Now, first derivative test shows that. The second derivative test, oh, by the way, no critical points, no min max. That should all be common sense by now, since you did the homework and everything, right? So if you don't get a critical point, you don't have min max. In this case, we did not have a critical points, therefore no min, no max. All right, the next order of business is the second derivative test, so we have to take another derivative. And the second derivative of x would be positive 2 over x cubed, I believe. Yes. And when you set that equal to 0, we get no solution. which implies no inflection point. But just like for the first derivative, remember the procedures are identical, you still have to partition on the asymptote, because that is the vertical asymptotes. So for both tests, you partition over the special points you get. For the first derivative, it's critical points and asymptotes. For the second derivative test, you partition over inflection points and asymptotes. So vertical asymptotes are always in the game. In this particular problem, we do have a vertical asymptote at 0, so that's where we partition. Choose two test points. You can choose whatever you want. And now perform the second derivative test. So I have 2 divided by -1 cubed, which is -2. That's less than 0, which means function is concave down. And this one, when you plug in 1, we get +2, so function is concave up. So function f of x is concave down on -∞ to 0, and f of x is concave up on 0 to infinity. Done. So now all it's left is for me to try and graph this with the information that I have. If I need more points, I can always compute them using whatever we learned in middle school. You plug x for x and you find y's. So what do we have? We have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 0. We do not have x's and y's, x and y intercepts, and we do not have any critical points, any inflection points, so we have no points to put. Usually you like to start these graphs by putting a point somewhere and then trying to develop the graph around it. Well, we are lucky kind of we have these asymptotes, because when you have asymptotes, the function can either go like this or like that to follow those asymptotes. So all I need to do is to make sure that I have, as you can see, you can't have both, right? Because it wouldn't be a function. So all I need to go now and look at the either first or second derivative test and steal information on concavity from -∞ to 0. So second derivative test, concavity, first derivative test, increase, decrease. Observe that the upper line is concave up and increasing, and the bottom line is concave down and decreasing. So that has to match. Now, if I don't even need to scroll, I can just look at the top of the screen and it says that on -∞ to 0, function is concave down. Well, that tells me that I have to erase the upper part because the lower part is the one that it's concave down. On the other side, since I have these two asymptotes, I can draw a function in this fashion. So, in order for my function to follow both asymptotes, I either draw the upper or the lower. So now I look immediately up. From 0 to infinity has to be concave up. This one is concave down. So I will erase the one on the bottom. And there it is. This is the graph. We all know this is the graph for 1 over x. Cool? Of course, cool. It's calculus. So let's graph one more using all these amazing methods. How about y equals, or f of x equals, whatever you want to call it, x squared plus x minus 6 divided by x minus 5. This is something that you should be able to do now because you studied this in your pre-calculus course, section 2.6, graphing rational functions, where you did this list halfway. You did everything on the list except first and second derivative test. If you look at your list, the one that I gave at the beginning of the lecture, half of this list is calculus and half is pre-calculus. And whatever you have in the pre-calculus half of this list, it's actually sufficient to solve the problem below. But you know what? Sometimes you want to hang in a little, picture, and you have a little nail, but all you have available is a sledgehammer, so hey, why not use it? It's going to be one hit done, right? And then you do spackling and everything else. So let's see. The first order of business here is to check domain. We know that domain is the set of all values that are allowed to be plugged into this, right? So what is, in this case, the only value that doesn't work? 5. So we are going to get the domain as negative infinity to 5 union 5 to infinity. And we see that looks like this 5 is the only problematic point that we might run into, so we'll keep that in mind. Might show up again. The next order of business is X-Intercept. Well, for X-Intercept, set y equal to 0, which means x squared plus x minus 6 over x minus 5 equals to 0. And when you cross multiply, you just have numerator equal to 0. Now, if you know and factor this, you will get x is negative 3 and x is 2, which gives us negative 3, 0 and 2, 0. And you know what? When we start doing more complicated problems, I like to box all of the answers that will later help me figure out where to, plug points and so on the graph. So that was the X-intercept. Now we go for the Y-intercept, where we set x equal to 0. And we clearly, dare I say, have negative 6 over negative 5, which is 6/5. So 0 and 6/5, that's 1.2, right? 6/5. So easy to graph. The next order of business are asymptotes. Do we have vertical asymptotes? Yeah, where? Very good. So we do have a vertical asymptote at x equals to 5. Nice. How about a horizontal asymptote? No. Slant? Oh yeah. Why is it oh yeah? It is, but by 1, exactly. So the degree in the numerator is by 1 higher than degree in the denominator, therefore we do have slant asymptote. And to find that, we are going to do a simple long division, exactly. So if you don't remember synthetic division, well, don't worry about it.
Do you really not have to worry about it?
Exactly. So 1 times, so drop it down, 5 times this plus 6, and then 5 times 6 is 30, but we don't care about that stuff. We just have y equals x plus 6. Because if you don't remember synthetic division, you can always go and say x minus 5 divided into x squared plus x minus 6, and then solve it that way, because that is the one that everyone knows, because it's the same as the long division of numbers. So x goes into x squared x times, multiply it back, we get x squared plus 5x, minus 5x, sorry. And then when you subtract, these guys die. This creates 6x minus 6. And then x goes into this plus 6 times. And we don't care about the remainder because we just need the horizontal, we just need the line. Now all of this is going on a graph as well. First derivative test. We take the first derivative. Now you can choose to use logarithmic differentiation. You can use your rules that you learned in class. Let's use the quotient rule because we can. So x minus 5 in the denominator goes there, and then x minus 5, and then we have, what do we have? We have 2x plus 1 minus x squared plus x minus 6 times the derivative of x minus 5, which is just 1. So now what do I have? When I FOIL over here, I get 2x. I get 2x squared minus x is just x squared. And then I have x minus 10x is 9x. So 8x. So one more time. I think that should be a negative, right?
Yeah, negative 5 times 2.
Yeah, that's negative 10 and then negative 10. And then
So you have 1 plus x, 1 minus x. So you should have just 10 minus 10x. Not 8x.
Yeah, it's negative. No, it's negative 8x and then the 2 positive x's. So it's negative 10x and then the 2 positive x's.
I have,
No, you're going to have
Plus x
plus and minus x.
minus 10. And then the negative distributes to the constant.
so it's negative 10x.
Okay, I agree.
With a smile. And at the end we have negative 5 plus 6 plus 1, I hope, divided by x minus 5, everything squared. So now I have this, and we know that we have to set everything equal to 0. Now when you cross multiply, denominator dies, and that's why we don't have to worry about factoring denominators, foiling denominators. We can just ignore them, because when you cross multiply, the 0 will always kill the denominator, and we are only looking at this. Now, you know, if you're masters of quadratic equation, you want to do that as soon as possible because you don't want to waste time. This would, in this case, would be 10 plus minus square root of 100 minus 4 times AC. That's just 4 divided by 2a. So we have 10 plus minus square root of 96 divided by 2. Now, for purposes of this problem, I know it's not exact, but it's pretty damn close. Square root of 96 is 9.9 blah blah blah, right? It's like 10, all right? So you actually have 20 divided by 2 is 10. And we are going to use the exact value. By the way, 96 is divisible by 16, is it? Or is divisible by 4, I know that. Divided by 4, you get what? You get 20...
It's 2 root 6. It's divisible by 16.
Oh, is this by 16? Okay, great. So 2 root 6. Nice.
4 root 6, right? Because the root 16 goes to 4.
And then this cancels to 5 plus minus 2 root 6. Great.
It's 4 root 6.
You cancel by 2 now. So now we have our x values. This is where the partition happened. The first derivative test, right? So what do I have? I have a crooked line, which will be fixed. From negative infinity to positive infinity, I have vertical asymptote partition at 5. So I have the critical point at 5 minus 2 root 6. Then I have partition at 5, and then I have a partition later down the line of 5 plus 2 root 6. So we have 5 regions here to worry about, right? Not 5, sorry, 4. 4 regions to worry about. You see number 5 is in the middle, and then you add or subtract 2 root 6. So now we pick test points in each one of those regions. Root 6 is over 2. So we know that we can pick 0 on this side. We know we can pick 4. We know we can pick 6. And then that's at most 5, so we can pick 10. And we have to check all of these test points to see which way it goes. Now, remember how your first derivative looks like. That's this beast over here. So now you get to plug in each one. You see how these problems, this is still the basic pre-calculus problem done calculus way. Like when you have a ln of x squared minus 1, it's going to be a little bit more calculations. What? Did you leave your canoe? Is it pouring over there? Nice. F prime computed at 0. So that becomes 1 over 25, which is positive, which tells us that the function is increasing. F prime computed at 4. So what do I get? 16 minus 40, negative divided by positive. I'm not even computing it, as you can see. What I did is I just did the analysis. We have, when I plug in the first derivative, whatever it is, there it is, x squared. So 4 squared is 16. 16 minus 40. I don't even want to think what it is. I mean, I know what it is, but I don't need to calculate anything else, because plus 1 is not going to change that to a positive number. And I have square in denominator, which is making sure that the denominator is always positive. So you have the negative divided by positive. We don't need the exact values for the first derivative test. We just need to know whether it's negative or positive. Negative means function is decreasing, and positive means function is increasing. So I just use the analysis here to quickly determine that the derivative is negative, and because of that we have a decrease. Now we repeat the same procedure for number 6. We have 6 squared, that's 36, minus 60. Again, we have the same situation, so negative divided by a positive, which is less than 0. And we are left with f prime times 10, right? F prime of 10. So that's going to be a positive value, because you get positive divided by positive. You see, when you have 10, then 10 squared is 100. So you have 100 minus 100, that dies. So you just have 1 over something squared. 1 is positive, square number is positive. Positive divided by positive is positive. So, boom, increase on this side.
Professor, you don't even realize how good you are. That's also 1 over 25. As is
What?
the first one.
No.
F prime of 0 and F prime of 10. It's your math instincts to find math powers. You just knew without even knowing.
No, but we generally don't care.
Yeah, no,
Because we just need to know whether it's positive or negative. I calculated the first one. Well, it was easy, but the second one is also easy because it's the same, right? But anyway, so I immediately found that at x equals 5 minus 2 root 6, I have a minimum, and x equals 5 plus 2 root 6, as you can see, we have a maximum. Remember how I told you the first derivative test will give you critical points, will give you increase, decrease, will give you min, max. So there you go. Previous problem did not have critical points, therefore we couldn't get min and max going. But now we do. Now this was enough for a long time for us to graph, but you know what?
Wait, yeah, Professor, wouldn't it be the other way around for the min max?
Why? Oh yeah. I was testing you. Very good. You're paying attention. Life. Second derivative test. So we have our first derivative as x squared minus 10x plus 1, right? Yep. Divided by x minus 5 squared. So now we have to take another derivative. And what better to use than our good old trusty, the best of all techniques? Anyone? Logarithmic differentiation. Copy the whole thing and then just take those derivatives. So copy the function. Times 2x minus 10 divided by x squared minus 10x plus 1, and then minus 2 times, so I mean 2 over x minus 5. And now all of that equal to 0. Now before you explode, each one of these independently gets set to 0. So we have x squared minus 10x plus 1 equal to 0. Denominator multiplies into 0 and gets wiped out. And we already know these answers. Yes?
You go through how you found the second derivative again.
I use logarithmic differentiation.
From where did you get the minus 2 over x minus 5?
That's the denominator. It will be minus 2 ln of x minus 5.
Oh, because it's to the negative. Oh.
Negative because it was in the denominator. So we're going to drop this side because those were critical points before. We know them as a min and a max. Can be inflection at the same time. But then we have the other equation to play with, which is 2x minus 10 over x squared minus 10x plus 1 equals 2 over x minus 5. And if you cross multiply, you can factor out 2. Look what you had. Twos drop. We FOIL. Wait, something is wrong here because I'm getting the same thing. Oh, no solution here either. Okay. So 10x minus plus 25 is equal to x squared minus 10x plus 1. And you get 25 equals to 1, so no solution here. Perfect. So no inflection points. But we still get to partition because we have a vertical asymptote. I just hope you don't forget that. So it doesn't matter if the critical points or inflection points are not there. You still might have vertical asymptotes. And even if the vertical asymptotes are not there, then the entire domain does the same thing. So just pick any one value from the domain and analyze that. You always have something to work with. And in this case, no inflection points, that's not a big deal. We are going to pick numbers 4 and 6. And work the second derivative at 4. Now, in this situation, we do have to calculate. And the reason is, you have to calculate because of this term here. That term is going to give us plus 1. But we don't know how much, right, is this going to be, because whether the whole parenthesis is positive or negative depends on the values between the two. Whenever you have a subtraction or addition like this, you actually have to compute. So those are bad news, but I guess we'll live. So what do we have? We have, computing a number 4, we have 16 minus 40, which is 20, very good, plus 1, so 25 over 1, so that's a 25, and then I have negative 2 over 25, and this is 4 minus 5 negative, so plus 2. We are again looking for either less than 0 or more than 0. So this is going to be 25, so that's 50, 48, 20. Is this just 48? Yep, just 48. So we have a concave up over here. And now we repeat the procedure. So plug in 6, we get 36 minus 60 is 24.
So isn't that 23, not 25?
I'm not sure where.
First you had the 25, right? From the x squared minus 10x plus 1? Oh, from here. Okay. Never mind.
And then x's cross, right? These guys cancel. And these guys cancel. And you have 25 equals to 1, which is not good. All good? So now when I'm plugging in a 6, I'm getting 6 squared, that's 36, minus 60, that will be 24, plus 1, again 25. And then this is positive 2 over 25, and then 6 minus 2. So that's negative 48, concave down. Let's graph. I start usually with points or the asymptotes. So vertical asymptote at 5, slant at x plus 6. You know what? I'm going to go for all asymptotes, let's say blue. So x equals to 5. Wow. So that's at 5. And I have the points. So 0 and 6 over 5. Now 6 over 5, I already told you, is 1.2. Right there. Now X-Intercepts. See you next week. -3 and +2.
You want Y-intercept before or X-intercept?
Wouldn't that one be 1.2 be on the y-axis?
Right here. Yeah, that was a Y-intercept. Yep, Y-intercept on the y-axis, X-intercepts -3 and +2. So those go on the list. So we have those. Now, we have the slant asymptote, yes. So it was x plus 6. Oh, it's gonna be bad because it's so tall. 1, 2, 3, 4, 5, 6. And we have the slant asymptote. Now those asymptotes will intersect and cross each other. So now what do I have? Well, I have to draw this graph much smaller. I'm keeping the same graph. You don't have to erase anything. It's just I'm going to make it smaller so I can fit everything on it. If you haven't started yet, that would be awesome. But if you did, don't worry about it. maybe I need to zoom in a lot, so let's try. Yeah, they're intersecting. Good. So that's where the 5 is. That's where the 2. I can't find it now. -3 and 2. There we go. There we go. Now, when you have two functions intersect, you can have two asymptotes intersect. These are your possible choices. Because for a main part, they have to follow asymptotes. Sometimes you can pierce through horizontal or slant asymptote, but for the most part, they follow. Right? So now let's see. I know I have X-intercepts at -3, 2, and then there's that 1 and 1, whatever it was, 6/5, which is right here. Exactly. Very good. So it has to be here. It's going to follow, cut through those, and follow down. Now, the other piece, it's either going to be on top or the bottom of the right side of the asymptote. You can't have one piece on top because it will fail to be a function. So be very careful. Now, what do I have for the other graph? Because now I established the left-hand side from the asymptote, now I need the right-hand side. So which one is it? This one or the other one? The answer is could be any of them, right? So now we have to think a little bit, and you have a choice. Your choice is to compute a single point, or go get to compute with those ugly square roots, compute the function value to see whether your min or a max, whatever we're getting, is above or below the slant asymptote. I would say just compute number 5 in original equation. Sorry, not number 5, number 6, because number 6 will give you a value that is either underneath or above. If it's underneath, you draw this piece. If it's above the asymptote, you draw the other piece. So I'm going to compute the additional point for the first time, and additional point is f of 6. And I'm doing that just because I'm lazy, because I could do the critical point and then figure out the value for it and then use that. But f of 6 will work as well. What was the problem 30 years ago?
X squared plus x minus 6 divided by x minus 5.
So x squared plus x minus 6
over x minus 5 is 36.
30. That's way over. That's well over. So the last piece is here on top. Right, that's 36. You want to verify that? You plug in your you plug in 6 into slant asymptote. 6 plus 6 is 12. So the elevation at 6 for the asymptote is 12, and we got 36. So it's 3 times more. I need that ta-da button. I gotta find it somewhere. Okay. There you have it. I know, fun, right? These problems are not hard, they're just a grind. You know, a lot of components to get. To be very careful not to butcher the derivative, and then that kills everything else. So I'll give you one example to try. See how that goes for you guys. Again, it would be good to collaborate with people, but make sure you're doing this problem because final is next week. Exactly, next week.
9 days.
Yeah, in 10 days, Calc1 will be just the past for you.
Yeah, professor, 3
He-
weeks from today, we start nightly integration.
Yes, Calc 2.
Oh, yeah.
Exactly. Get it over with.
Yeah, no, that's really nice. Honestly, I think I'm just gonna do like as many class preps as I can over the little bit of break, and then go through some of your old streams.
Yeah, I know one student is already doing that.
Professor, when is our next test, most likely? When we're gonna be done with chapter 4?
I have no clue. Hopefully soon.
Yes. Yes, and too loud.
All right, so here's a cool problem for you to try. This should go quick, I hope. No, no, no. Tangent inverse of x squared should go quick. Yes.
hard because he's giving us like tricky questions on purpose, I guess. But like, like I was on cramming like average and stuff. Aren't you taking that?
I just took the final for that today.
Help.
How was it actually? So you memorized like all the bones, joints, muscles.
Yeah, we did that for the road.
So what did you do now? Like nervous system,
Arteries, veins, embryology, diagnostics.
No, I would do my best not to mess it up.
Urinary system, kidneys, nephritis, and digestive system. Digestive system is the hardest.
that was like my second exam. Such a great like ours is gonna finish, like the practical is gonna be on like the bones, muscles and stuff.
It's not too hard.
This next exam is gonna be nervous system. Like no, yeah, nervous system and the brain.
Where's your ilium? Top of your hip bone.
Oh, yeah.
Where's your coccyx? Coccyx.
Yeah, -2 wasn't 2, so it's -1. I'm sorry.
Yeah. At the bottom of your spine. Small bone. Yeah. Where's your mandible? Yeah. I'm gonna give you the
Where's your
okay. You know me.
literally just went over the muscles the first time. Like bones, like yeah.
Do you guys know the veins?
Like what about
You can know the eye, how the veins are.
like not specific.
I went through the same episode of the other ones in my horoscope.
Oh, that's interesting.
Yeah. I read my horoscope and I'm like, this doesn't make any sense.
Oh, I read mine and I was like, damn, what happened in so much?
Wait, what are
Because
your
like
signs?
part of it sounds
I'm an Aries.
Scorpio.
I'm Capricorn. It's all bullshit though. Especially the love stories.
I'm like obsessed with it. I don't know why. And like this guy, like I like looked at his and I was like, ours match and we're hanging out on Wednesday and I was like, ooh.
What sign is he?
Capricorn.
He's like, I approve.
Capricorn.
We like dated and then like things got complicated and now we're getting close again.
That's good.
So like, he wanted to happen again. But it's so shitty though, because like he started calculating and he was like, every time I see him he's like, if you need help, like let me know. And like things were like getting weird and it kind of with me, so I was like, what? So I said, you help with calculating. I was like, hey, you wanna help me with asymptotes? He's like, yeah, come over. So he
can't, but supposing with Capricorns you can. Like for Capricorns it works for some reason. I mean, that's not how reality went.
There's so many more.
The word was so funny. I think of actual porn.
She's the one that like got me into all that shit though.
When you post it.
Yeah.
I feel like I never share it with
Two
you. Like I
of
think I just like reading it and it makes me feel a little bit better about myself.
One.
I really think like the daily, weekly
One
ones are
dies.
like-
I read the one
Do the Cosmo weekly one on Snapchat.
Like as far as like personality traits and all that shit, that's like really true.
Yeah, I like reading them like the weekly ones after the week, and then when you like start to like, okay, that actually happened. That's when I'm like, yeah.
You know, like there's like a science behind it. Like they write like very big things.
Yeah,
Yeah,
it's
yeah.
so weird.
My one friend, and like his are always exactly so weird. Like one week for this, like you're gonna go on vacation.
All right.
Person on Friday, and like.
So this one was easy, right? Quick. Yes, no? So where do we begin? Well, first X and Y intercepts, that's, no, domain, sorry. Domain is from negative infinity to positive infinity, all real numbers, because we can plug in any value for X, right? You square it. And then inverse trig functions have all real numbers as domain, so we're good there. The X-intercept, we set y equal to 0, so inverse tangent of x squared is equal to 0. We apply tangent to both sides. We get x squared equals to tangent of 0, which is 0. And we get 0, 0. So as soon as you have 0, 0, that for x-intercept, that's immediately y-intercept as well, because it's at the origin. So we have 0, 0 to be both x-intercept and y-intercept. Awesome. The next order of business are asymptotes. So do we have a vertical asymptote? No. And that should be common sense because domain is all real numbers. It's not interrupted, right? So, clearly. Now, do we have horizontal asymptote? And that is hell yes, right? Yes. So horizontal asymptote is yes, and then we need to figure out where they are. So for inverse tangent of x, we have asymptotes at y equals plus minus pi over 2. That should be common knowledge because you know the graph for inverse tangent. It has asymptote at because the tangent x has vertical asymptotes at negative pi over 2 and positive pi over 2, the inverse tangent must have horizontal asymptotes at negative pi over 2 and positive pi over 2. So that's the logic. So now for inverse tangent of x, we have these asymptotes. So what does that mean for the other one? They're going to be at the same spot. So that's that. Slant asymptote, obviously none, because we need those polynomials there to be at work. Now, the next order is the first derivative test, not rest order of business. And the first derivative would be 2x over x to the 4th, right? And when you set that equal to 0, what you get is x equal to 0, which gives you 0, 0 as the critical point. So now when we do partitioning from negative infinity to positive infinity, we have 0, and we pick two values, negative 1 and positive 1, let's say. And the first derivative computed at negative 1. First derivative computed at negative 1 would be 2x divided by 1 plus x to the fourth. Denominator is always positive, so we have a negative divided by positive. That's less than 0. We have a decrease. And the first derivative computed at 1 is now positive divided by positive, which gives me larger than 0. So we have the increase. So it appears that there is a minimum at our critical point. Second derivative test, we need second derivative. You can use quotient rule, you can use logarithmic, whatever makes you happy. So if we are to FOIL all of this, I get 2 plus 2x to the fourth minus 8x to the fourth divided by 1 plus x to the fourth, everything squared. So second derivative is equal to 2 minus 6x to the fourth divided by 1 plus x to the fourth squared. And now when we set that equal to 0, again, denominator dies instantly. All we have to worry about is 2 equals 6x to the fourth. So x to the fourth is equal to 1/3. So x is equal to plus minus 4th root of 1/3. Which is also some very small number, which actually partitions for us. We have negative 4th root of 1/3 and positive 4th root of 1/3. So clearly we can choose negative 1, 0, and positive 1 as test points because such is life. How about that? Easy. So f double prime, when I plug in negative 1, that's going to be negative divided by a positive. Denominator is squared, so it's always positive. We have less than 0, so concave down. When I compute at 0, I have concave up, because concave, that's just going to be positive, which is 2 divided by plus, right? And then the last part is at positive 1. When I do the positive one, I get negative divided by a positive. They don't always alternate. Be careful about that. In this case, they did. Nice. So let's graph.
Professor, wouldn't it only alternate if your powers are even? Or is that not always how it works? Can you have even powers and it's still not alternate?
Yeah, it depends on the denominator, and there are a lot of other aspects of it. So I have a 0, 0. We know it's a minimum, so we get to put a smiley face there. There has to be an asymptote at pi over 2. We know there's an inflection point, so this has to bend and follow the asymptote. There we go. Awesome. You can see it's concave down up to inflection point. Then it's concave up, the little smiley part. And then again, concave down after. So these points here are negative 4th root of 1/3 and 4th root of 1/3. Those are the stick marks. And then you have 0, 0 for the minimum, and so on. Cool, right? All right, so one more, and I hope you guys will spend a few hours cranking these at home. So what should we do? Let's do one of the LNs, because they have a lot. Problems 30, 32, 33, they all have LNs. $32, $33, $30, which one? $33. All right. Not going to be a problem for you. Always. This is the moment I open my eyes in the morning. Intent.
Well, he thought it was some demonic possession. They fixed that.
sad.
She had to sit there for hours and hours and hours. Figure out. You can't even grab and try writing that. I know it's weird. So now, but you know, if you spend hours every day, you'll definitely.
You develop those fine muscles.
Yeah. No, because we're growing. Yeah, let's see, we're growing in a society where that is, you know, but you know, go back to what, 1960s? In Serbia. Yeah. Don't mess around.
They don't mess around in Serbia.
Oh, you got 1 point out of 15.
That's so true. Walking out of school like all energized and stuff. And you're like, where was this energy coming from?
That always happens. Supposedly it's like when your brain thinks you're not doing, or you're doing something that's not important. It tries to like save energy and like start shutting down. When you're tired. Yeah. It's so fun, right?
You want to take on the board?
No.
Why not?
I don't want to.
Go?
Oodles are fun.
Draw a picture.
I'm not feeling this.
You reward myself for staying so long. Maybe you'll buy some dark chocolate. Put some wine. Or not at the same time.
Not at the same Let's not party too hard.
So it's gotta be fine.
School night.
Yeah.
Colors. When are you graduating?
On Thursday.
So many days. I feel like everyone else is young.
I know.
Actually, my ex is a teacher. She's gonna be teaching that teacher's 27. Like, yeah, she teaches at like a charter school. I guess they just took like a lot of days off this year.
What's up with teacher?
Spanish teacher.
All right, so let's go through this and then move to 4-4. Yay. Finally is next week.
Such a
2
random
chapters to go.
second.
I know.
What's your sign?
You said you were ahead.
Yeah.
Yeah.
Yeah. So, domain is 0 to infinity. We know that anything can be plugged in for x, but ln x can only take 0 and up. So we only consider these values. Then we have our x-intercept, y equal to 0. That's x ln x equal to 0, x equal to 0, and ln x equal to 0. X equal to 0 is x equal to 0, but it's not in the domain. Not in the domain. Oh, come on. And ln x equal to 0, if we e both sides, right, to solve it, we get x equals to 1. Now that is in the domain, so we do have one x-intercept, and that's 1, 0. Now we want to know the y-intercept. When x is equal to 0, nope, right? Because we can't have x equal to 0. Right? Ln of 0 is negative infinity. Then we move to vertical asymptotes. And we know that we do have one at x equal to 0 because of ln. Horizontal asymptotes is none, because ln has a vertical, not horizontal asymptote, and x is a polynomial that has no asymptotes, period. And obviously slant asymptote is none because, again, it's not polynomials. So we do have one of these that we have to worry about. And then we are immediately at the first derivative test. We take the derivative. It's a product rule, so copy the first one times derivative of the second one plus copy the second one times derivative of the first one is 1. So the derivative is 1 plus ln x. And we set that equal to 0 to get ln x equals to negative 1. When we e both sides, we get x equals 1 over e. So we have a critical point. We have to find the y value for it, but we have a critical point there, so let's find the y value. Is 1 over e times ln 1 over e, which is, that's a negative 1, so negative 1 over e. So I have 1 over e comma negative 1 over e as the critical point. I don't know yet what it is. Should be something. Min or a max. We'll see. Let's partition. I start partitioning at 0. Remember, domain doesn't exist past 0. And then we have 1 over e as value. And now we have to pick values to test. Now, what are the cool values? Remember where we are plugging this in. We are plugging this in the derivative. Derivative has ln x. You can plug in any number you want. You still have a calculator. You don't have a graphing calculator, but you have scientific calculator. So no matter what you pick, it's going to work. I'm going to pick smart values because, you know, 1 over e squared is a good value because if you make the denominator larger, you make the whole number smaller. And again, since I have ln, I can use e easily because this is actually e to the minus 2, which is easy to compute. And then I'm going to pick e over here because I can. E is a number that is larger than 1 over e. I'm picking these values because I'm lazy and I don't want to use calculator. So it's much faster for me to compute this way. So first derivative computed at e to the minus 2, which is 1 over e squared. When I plug that in, I get 1 plus ln e to the minus 2, which is 1 minus 2, which is negative 1. That's less than 0. I have a decrease. And the first derivative computed at e is just 1 plus ln e, which is 2. That's larger than 0. So our point over here is the minimum, right? It's a minimum. Cool beans. The next is second derivative test. So we have to take the derivative of 1 plus ln x. Second derivative is a joke. The too bad I didn't keep this one for the test. It's easy. Equal to 0, no solution. So no inflection points. So the entire thing is one partition. We only have the vertical asymptote at 0. And you are plugging in 1 over x. So pick anything between 0 and infinity. Test point 1. And do the second derivative test at 1, which is 1 over 1, which is 1, which is larger than 0. The entire thing is concave up. Right? Nice. All I need to do is to graph this. So we draw the straight line and then another straight line. We know there is nothing to the left of x equal to 0. And to the right we have a point 1 over e, negative 1 over e. And we have the X-Intercept. X-Intercept was what? At 1. That's the X-Intercept. We have the vertical asymptote there. And we have a minimum at 1 over e, negative 1 over e. Now 1 over e, that's e is about 2.7. I'm sorry? Oh, you took all the fun out of it. Okay. 0.368. So let's say it's here. Oh, there has to be another X-intercept. Because the oh no, doesn't. The function starts with the open circle at the origin and goes like that. So, you know, all the graphing calculators and utilities kind of took fun out of this. But just 50 years ago, you had to do this by hand every time for every single function. Great. All right, we'll restart with 4-4.